All right, good afternoon, everybody. So as usual, I'm going to be a little bit short on time, so I'm going to jump straight to what the thing, KG-OBO, in my title actually is. So KG-OBO stands for Knowledge Graphs of Open Biological and Biomedical Ontologies. And I assume, considering this is the ontology section, that everybody's familiar with the concept of an ontology, at least. I'm not going to be too worried about that. The concept of a knowledge graph is a little bit fuzzier. People tend to use it a little bit differently. And we actually didn't talk about OBO ontologies quite as much as we expected. So I may have to just briefly mention that. How many people in this room are familiar with OBO Foundry? By show of hands. Yeah, the majority of people, but not everybody. So that's okay. So what's the kind of challenge that we're dealing with? So as I mentioned, that first initial challenge is, okay, well, what's a knowledge graph to begin with? I'm just going to define it as a heterogeneous collection of concepts or entities and their relationships. So that's a pretty high-level definition as they go. If you go out on the internet, sometimes people are just like, oh, it's a thing that Google invented. And that may or may not be true. But at least in biology or biomedicine, it's a pretty convenient data structure to be able to represent those biological relationships that we're all interested in. So that may involve instance data of events like, okay, a patient that's one of these nodes or V1 has a disease phenotype V2. But then you can also combine that with the more conceptual observations like, okay, that disease phenotype V2 involves a particular protein V3. So the kind of data relationships that we're generally pretty familiar with. So how do we consistently complement a knowledge graph and the relationships in there with that domain knowledge? And this is something that we heard about in Melissa Handel's keynote not long ago. So if we want to be able to say something like, okay, V2 is a vascular disorder and V3 is involved in ion transmembrane transport, and those are really critical to understanding the nature of those connected relationships. Well, first of all, we need to be able to join all those varied relationships in one consistent graph structure. We know biology has already made a relationship, so that's intuitive, but biology itself is pretty messy. We saw that too in comparing multiple ontologies and different understandings of what a disease might actually be. How can we actually make those relationships more searchable within the resulting knowledge graph? And then how can we actually learn new relationships among those connections within a knowledge graph? So how do these open biological or biomedical ontologies actually help? So OBOs, you can find out a little bit more on the OBO Foundry, and there's a pretty recent paper on them as well, but they're all collections of hierarchical domain knowledge in biology. Quite conveniently, they're available. They have generally very rich term descriptions. They're standardized and validated by a variety of fairly rigorous criteria. They're consistent format and structure, and they have very rich metadata. So we have a lot to work with here, and they cover a fairly wide array of different domains. They're also compatible with an open toolbox like the OntoDev tools that we just heard about. So things like Robot and increasingly more integrated toolboxes like Oak really work directly with these OBO ontologies very well. So I guess my immediate question here, in pursuing the idea of, okay, how do we actually merge OBO ontologies into knowledge graphs is, okay, why not just translate them into a graph structure? They're all pretty simpler structures in the end, right? The problem is that graphs are not ontologies. Ontologies are domain or task specific, and that may not exactly match the kind of level of detail that you're working with in a knowledge graph. We also know that the relationship types vary between ontologies and what you may also have defined in a knowledge graph. It's highly unlikely that they are exactly the same. We also know that content and usage varies, even when the format is consistent. One or two different ontologies may have different content, different planned usage, and the same may be true of the knowledge graph that you're trying to combine them into. Even at the same time, we know that data models vary. We heard a little bit about the BioLink model earlier, and that's in fact what I'm using in this project. But that doesn't solve a couple of the other problems that we get to, like, okay, how do we even keep track of versions? We know there are different versions of ontologies, there are different versions of knowledge graphs, but we don't always track the exact provenance. It's not always easy to get to the older version of a particular ontology, even if you've you've transformed it a couple times, or maybe especially if you've transformed it a couple times. It's also massively inefficient to translate every time you need to ontology to be added to a knowledge graph. If you're working with something like NCBI taxonomy, you really shouldn't need to translate that into a graph structure every single time you want to use it. Or same for something like protein ontology. So long story short, if this is a problem that you're facing, I say go ahead and first you can visit the code to assemble OBO ontologies en masse into knowledge graphs. So you get standardized ontologies as graph nodes and edges in a nice, consistent, intelligible format, complete with version tracking. So the versions are all kept. If they don't adhere to exactly the same expected format, well, we assign them a version. So we're actually a little bit more permissive than the OBO Foundry itself is in terms of retaining versions, in that we'll freely assign the date that a new version came out if one isn't provided in a consistent structure. And most importantly, they are all publicly available on the internet. So how do we actually get that? Well, we start with OBO Foundry, take the more than 250 OBO ontologies that are on there. Some of them are obsolete, but we're focused on the non-obsolete section. We do a lot of pre-processing with Robot and with the KGX knowledge graph platform. Those are both publicly available as well, nothing secret here. And then we deposit them in a growing collection of carefully indexed knowledge graphs that we call KG-Hub. I'm not going to talk a whole lot about that today because that's still a work in progress, but suffice to say that is where you can find a variety of biological knowledge graphs for an array of different purposes. For the KG-OBO in particular, you can find it at kghub.berkeleyBOP.io/KG-OBO, and that'll give you the whole list of all the most recent versions of these OBOs as knowledge graphs. And you get a variety of artifacts that go with those as well, including JSON, the most recent commit of KG-OBO. So you can actually track the full provenance of creating these things. So what's actually in there? We have more than 200 OBOs as graph structures ready to plug into your favorite knowledge graph. We have more than 500 versions since we started collecting them in September of last year. By edge, most of them are from NCBI Taxon. Not surprisingly, that's an awfully big one. But we also have things like drug ontology, protein ontology, NCIT certainly take up a lot of space. But then we have kind of the long tail of other ontologies also available as graphs and their nodes and edges. So in practice, we have these nodes and edges are just represented as fairly convenient TSVs that I'd like to think are relatively easy to read as well. They're all in our consistent KGX format and the corresponding OBO IDs. Now, there are a couple limiting factors so far. One of them is that our node categories aren't always very detailed. It's not always immediately clear what the actual things inside inside an ontology are, or what kind of biolink category they should be mapped to. That's something that we're actively working on. That's something that can be done through a combination of those OntoDev tools like Robot and Oak, and as well as some improvements that we're adding to the KGX platform. Another limiting factor is sometimes the process of translating an OBO ontology to a graph structure isn't quite perfect, and some of that has to do with the idiosyncrasies of an individual ontology. Phenotype ontologies in particular do have some very tricky things that they like to do with their logic that make an awful lot of sense to them. They don't always make sense to me, but that does sometimes mean that they don't end up in the final graph. And again, that's something that we think is a solvable problem. So in the end, we think this enables some pretty rapid integration of ontology-based domain knowledge into these knowledge graph structures. We already have one knowledge graph called KG-IDG, so that's a graph based on the Illuminating the Druggable Genome project that we make a lot of use of KG-OBO ontologies in, but it also enables some really interesting graph-based machine learning as well, up to and including some training data for node-based label prediction, edge prediction, or even just learning over the OBO ontologies themselves and saying, okay, well, this particular component of the ontology is equivalent to this other component in this potentially non-mapped ontology. So in an instance like this, if you already have your instances, your concepts, and your knowledge graph, and you have something that you can link to something like, okay, well, this is Mozart ear. Right away you can say, okay, well, I know that's a subterm of abnormal ear morphology. So if that links to anything else, then, well, this is data that I can feed into a machine learning model and I can actually learn something from, or at least I can be confident that my model may learn something from it. So with that, I can take any questions if there are any, and if there's even a little bit of time. And I'd also like to thank everybody in the Bebop group at the LBL, as well as the folks in the Monarch Initiative team, who collectively have provided some great help and feedback on this and other knowledge graph-driven projects that we've especially been working on in the last year. So thank you very much.
Any questions in the audience? I'll sneak one in then for you. I wonder if you could give an example of one thing that doesn't make it into the graph.
Oh, one thing that I know does not consistently make it in the graph is really deeply defined logic. Like if it's defined in OWL, like 2 levels deep. Like I know some people call those sub-Q patterns. Right now, on the whole, they are just not getting in there at all. But soon, hopefully.